Hi, I'm Richard, and in today's tutorial we're going to be learning all about the Lindenmayer system, which is an algorithm that lets you create some pretty cool effects like this one. So let's get started. Hello and welcome on a cold and frosty November the 5th. Today in the UK we call this Guy Fawkes Night, where we burn in effigy of a man that tried to blow up the Houses of Parliament around 400 years ago, and we have fireworks and we have a good old time. But we won't be doing any of that today. Today we're going to look at this rather cool looking algorithm that can produce patterns like this and a whole host of others. Let me bring up the other screen right now. Let me just show you what I'm talking about here. This is called the Lindenmayer system, and it's another very straightforward to implement algorithm that can produce some pretty incredible results. Not just the leaf that you saw there, but some very famous curves called the cock curve, which is this one here. That's the Sierpinski triangle. Excuse me. Where's the cock curve? I'm not going to find it now, am I? Is it here? I thought it was here. This one here. Here we go. It's these triangles here. This is the cock curve. So you can create all of these really cool effects with a very simple set of rules. And if you like, each of the patterns that gets created is set up by a bunch of rules, and these are the rules here. So what you have is a couple of variables, or possibly alphabet, depending on how you see it. Constants, which we'll come to in a minute. You have a starting string. I call it a string. They're calling it an axiom, but we'll call it a starting string. And then what you do is you loop through that string, and every time you find an A in this example, you change it to AB, and any time you find a B, you change it to A. Okay, so you're creating a new string based on the old string, in this case starting with A. So you can imagine in this example, after the first iteration, it would just simply be AB, and then in the next one, it's going to be something like A, B, A. I'm not sure. We'll have a look and have a little play around and see what that's going to be. Okay, so from this rather simple foundation, we can actually create some really cool effects, including this one here that is creating this. This sort of, I almost think it looks like a tree that's been blown in the wind. Now, as you see at the moment, it's very flat, it's 2D. In a subsequent tutorial, I'm going to make this into a 3D, I'm going to find a 3D Lindenmayer algorithm, and we will actually make this look a lot more cool like that. But at the minute, we're just drawing this sort of tree in this, it looks like it's been blown from left to right, doesn't it? So let's talk about how we're going to do that. What we need to do first of all, I'm going to start a whole new project up. So let's just close this one down here and let me start up a new project. So I'll just say file new project, and then now of course because I've already created one, so let's just call this L system tutorial. L system tutorial. Yeah, tutorial. There we go. I might just put a dash in it. I don't like putting spaces in. Okay, it's a 3D, and we'll create the project. Alrighty, here we are. Sorry, I paused that then because it took a little bit of time. So let's have a little think about what we need to do. Like I said here, if we spin back to our thing here, let's just pull that across there so you can see a bit better now. So here we go. So you can see what the actual iterations are. It's showing you here. I don't know why I was guessing. And you can see as it goes on, it gets bigger and bigger and bigger with this A, B, A, A, B, A, B, 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 A. And you're thinking, well, what does this all mean? Well, it allows, like I say later on, it allows us to create with a sort of more advanced set of rules. It'll let us do that. But let's just start with a very, very simple script that's going to do this for us, and we can build on that as usual. So let's create a script over here, and let's create a C# script, and we'll call it L system generator. I've never been very good at naming my classes. Never been very good. So then we'll bring that into MonoDevelop. Here we go. So what we're going to need, what's thing called an axiom. So let's start with that up here. We'll just say public. Should we say public? I'm tempted to put private, and I'll tell you why I'm tempted to put private. Is because if I make any changes once you make it public, you can't change it in here. You need to change it in the inspector here. It's caught me out quite a few times. You can reset the variables or whatever, but if you don't do it in the inspector, then you can get quite confused sometimes. So for now, we'll just say private axiom equals A. Okay, and then private string axiom equals A. Excuse me. And we need to create a set of rules. So what I'm going to do is I'm going to create what's called a dictionary, and a dictionary is a key value pair. So what we'll say is the key would be the rule, so the key would be A, and the value would be what it's going to convert it to. So let's do that now. So we'll have a dictionary here, private dictionary. It's not going to like that. We're going to have to put using system collections.generic. Excuse me. There we go. Apologies, well, I do have a bit of a cough, so this may sound a little bit throaty today. I'll have a quick sip of my tea right now. 1 second. That's better. Right, okay. So dictionary, this is going to be a char, and why it's a char I will explain later on, and then a string of rules equals new dictionary, char comma string. Okay, and in the start menu here we'll have rules.add brackets, single quote, isn't it? A comma AB, and rules.add was it B comma A? I know it's slightly confusing with a single and double character. Let me just double check that. Yeah, so A is AB and B is A. All right. So what we now, what we'll do now is we will have a method down here. Let's just call it. We'll just call it generate or something like that. Generate. Void generate. Should we have void generate? And then what we'll do here is we'll obviously have a current. So we'll have a private string current. I don't want to say it, current string. Let's just call it current string, okay? And here we'll obviously say current string. Well, obviously, I say obviously. You might not get equals axiom. So it's going to start with A, and then we'll just build this current string up and up and up and up. Right? I don't like calling it current string. We can rename them later, can't we? All right. So what we'll do is here we'll have a string, new string, and then we'll make that quotes. And then what we say is we say for no, we don't. We're going to create a char array string characters equals current string dot to char array. Right, and that's going to make a bracket like that. So that'll create an array of single characters for us, which is why we can use this here. Makes it a little bit easier for us now. No, it's not liking that. I notice there's an error here. Current string dot to char array. Am I missing something? No, it's fine. I notice that red comes up sometimes. Alrighty, so where are we? So we've got our string here, and now it doesn't like that there, does it either? Oh, I haven't spelled private right, that's why. Private. Yeah, how's that? Happier? Yeah, okay. And then we will say for brackets int I equals 0, semicolon I is less than string characters dot length. Hey. String character dot length. I plus. Okay. And then what we do now is we say, okay, so the current character, so let's say char current character equals string characters I. And then because we've got our rules up here, all right, we should probably actually say if brackets hang on, what am I saying here? Well, no, let's not do that for now. I'll come back to that in a minute. Actually, let's come back to that. For now, we'll just say new string plus equals rules and then current character. Okay, so what that's going to do, it's going to, when you type something like that, that's what that does is that returns the value for this rule. So if it is A, it's going to return the value for A, which it will do in this case because there's only one character. So it's going to give us AB. Alright, so I think I'm pretty comfortable with that. And let's at the bottom here, let's just do a debug dot. Oh no, hang on. Then we need to say current string equals new string. So okay, so we're replacing it there. Alright. Okay, current string equals new string. Let's just do debug.log. Log current string. Okay. Alright, and then yeah, we're happy, and I think just to get us started, let's just type generate in here. So we'll have a look and see what happens. In fact, let's do it 3 times. Like so. I know this isn't effective, but it just proves the point. Okay, so what's going to happen is it's going to run through the string, it's going to get bigger and bigger, and as it comes across each character, it's going to add whatever that character. It's going to map that character to whatever it should here. All right, hope that makes sense. So we'll go back to Unity and we'll create an empty, like so. We'll just call it game object. I don't really care right now, and just drag our script in. And we've got the console down here. Let's just bring the console up over here so that it stays. One thing I don't know is maybe you guys can help me on this one. Whenever I click play, if I've got the console in the same window as game always comes up, and that annoys me sometimes. But here we go. So let's run this now. And here we go. We've got AB, ABA, and AB, AAB. Let's just have a little look at this and see how we're doing. Yes, this is the sort of thing we're expecting, okay? Great, great, I hear you cry, but what use is this to mankind? And indeed, you'd be absolutely right. It's not much good right now, although you can actually do some things with that very set of rules there. But the one I'm going to be looking at is a little bit more funky. It's going to create this tree effect, kind of like this one here. No, like this one here, although that looks like the opposite to the tree I've got, and I think I know why. And in order to do that, we need to get a little bit more funky. And if I slide down here, I'm actually not going to use this method that it's suggesting here, but it is best described as one that's not here. So yeah, no, that's not close enough. Okay, so let me get that up for you now. 1 second. Okay, here it is. My apologies, it was on the other screen. What we're saying here now is that if we find an F, oh, by the way, so we're going to need to change the axiom here to F. Okay, so this is our start one, and we'll actually get rid of those now, like so. So our rule now says if we find an F, then replace it with this rather funky looking string here, which is pretty scary, huh? What we're doing now is we're creating, if you like, a path that if like a turtle would follow with ink on its undershell that creates a line as it goes along. So what this is actually saying is move forward, and that's turn right by I think 25 degrees. This square here means save my position and rotation. All right, and then turn 25 again, go forward, turn left 25, go forward, turn left 25, go forward. This one here means, right, do you remember where you saved my position last time, position and rotation there? Go back to that, please. Then turn left a bit. Okay, now store my current position, please. Turn left a bit, go forward, turn right a bit, go forward, turn right a bit, go forward, and then go back to the position here. Okay? Pretty scary stuff, huh? But by doing a few iterations of this, as you can probably guess, we get a very, very large string indeed. And it allows us to create some very elaborate effects that will create that tree that we saw earlier on. So there's a couple of things we're going to need to do first. One of them is we're going to need to slightly tweak our code because this hasn't got a rule for these pluses and left brackets and right brackets. So what we'll need to say, this is what I was alluding to earlier on, is if brackets rules dot contains key current character. Okay, then proceed as normal. Do this new string plus rules. Otherwise, we'll say new string else squiggle. Let's just do that. New string plus equals whatever that actual character is. So don't apply any rules. Just add it. So if it finds a plus, it's not going to try and apply a rule to it. It's just going to put plus in this string here. So let's say new string plus equals current character. This is slightly annoying. .toString. So I have to convert back to a string again. I know we're bouncing to and from characters to strings, so I apologise if that's a little bit confusing. I could have made that a string as well, but it just is actually a lot cleaner this way, rather than converting strings to character arrays and then referencing the zero element. Sorry, that's boring. I'll move on. Trust me that this is pretty clean. So okay, so we're saying here, if rules contains that key, so if it contains the F, if we come across an F, then apply this lengthy string to the new string. Otherwise, just whatever it is plus. Alright, so let's give that a go. So yeah, we can do this, and then let's just do generate again. Shall we just do generate twice? Shall we generate bracket, generate bracket, semicolon, and generate. I know we're not doing this quite right, but that's okay. Alright, good. And that's going to create our string for us. Obviously, we're not doing anything with this string yet. In a second, I'll show you how we're going to do that. Let's run it. Let's just have a quick look. Okay, here we go. So let's just... Thank you. And then we'll run it now. And I'm hoping... Yes, you see, within 2 iterations, we've already got ourselves a very, very large string. I think 3 iterations is what you need to... get that tree effect that I had earlier on that I can no longer show you because I've closed that project down. What's that? Yeah, that's my old. That's the script originally. So excuse me if I'm referencing that a fair bit. Where are we? Where did you go? Here you are. Let's just do generate one more time. And you can imagine this is almost exponential, right? Because every time you've got this, you've got all these F's here, and you're doing. So for every F, it's doing this again. So it's going to be quite lengthy. It's going to be 1, 2, 3, 4, 5, 6, 7, 8 times as large as the last one, I think, if my maths is correct. So spinning back here, we run this again on the... Did I click it? I'm never sure if I clicked it. There we go. Yeah, so you can see now this has got extremely large. And to you and I, it makes absolutely no sense. Can you imagine trying to type this out by hand? But you can see that it's going to do something. So it's going to go... I don't know if you can see that. It's so small. But it's going forward, plus, store your position, plus, and then forward, turn left, forward, turn left, forward, blah, 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 and so on and so on. So this storing the position thing, by the way, we need to think about occasions when it's got... I'm not going to find one now, am I? I don't know if you can even see them, but you can see what's happening here. Sometimes we're actually storing the position twice, and what we need to do is create the concept of what's called a stack. Now, a stack is, for those of you that didn't do assembly back in the 80s, you lucky devils, if any of you are programming assembly now, then I salute you. I can only assume that you're doing that because you have to, not because you want to. But if you would do it because you want to, then you are some crazy guys, and I respect that. So, but for those of you that have never used assembly or aren't aware of the concept of a stack, all it is very simply is, imagine if that you were writing some information down on a piece of paper, and you put that piece of paper on a pile. And that would be called pushing onto the stack. And then if you pop something off the stack, all you're doing is taking the top sheet of paper. So taking the last bit of information that was stored. All right. So it's what you call a last in, first out approach. So you only get the last bit of information that you stored. So we need to think about how we're going to store our positions as we move around this tree. But let's crack on with just initially starting to move this thing around. So what we'll do is, for every generation now, we need to say, right, okay, so we're going to start in a certain position and we're going to start moving around. So let's just, now we've done this bit here, let's go down to here, and now we've got our new string, so we can say for brackets int I equals 0. In fact, we need to create this again, okay, to get the new version of the string. Alright, if I equals 0, I is less than string characters dot length and then I plus plus. Okay, and now we say, right, so we say if bracket, so let's get the character. This is very similar to the last one, isn't it? Like that. Okay, and then if current character equals I, current character equals F, excuse me, then we're going to move forward. Okay, and by move forward, what I'm meaning here is that we're going to move our game object around, but we're going to be drawing a line between each point as it moves around. Okay, so I'll come on to how we do that in a second, because I'll tell you one thing, my top bit of advice: if you're ever going to do a tutorial, make sure you know exactly what you're going to talk about. Don't think, oh, I'll wing it at the end, because I have just spent 45 minutes doing a tutorial only to find I could not work out how to draw lines between points. Now, don't get me wrong, I know what debug.drawline does, but what I didn't realise is that it needed some tweaks, and I played around with it for ages, and I thought, oh, this is a disaster. So, yeah, my top tip, people, for any YouTube videos, know what you're doing. Know what you're doing. Be passionate about it, love it, but certainly know what you're doing. Otherwise, you're going to get caught up like I did. So my apologies for waffling on about that, but just a top tip. I'm still learning. You know, I was going to do a video about how to present on YouTube and how to do tutorials, and I'm still learning myself, so I think I'm in no position to do that right now. I can certainly do one to, sort of showing you what I have learned. If anyone's interested in that, please let me know. But I think I've still got a lot to learn. The important thing is to be passionate about it and to enjoy it, and I hope you're enjoying listening to me. So let's carry on. So what we're going to say here, let's just do a couple of things as well. Let's just say forward length or something like that. So up here we'll have another private variable. This realistically should be public, but I don't want to make the mistake of keeping it in the inspector. So we'll have it float. We'll just call it length, shall we? And then so there we go. So that's fine. So now what we can say here is transform dot translate brackets vector3 dot forward, and then it will be times length. Okay, so what we're saying here is move forward by that length. Okay, a separate tutorial might be required if you don't understand why that actually works. This is a pretty standard way of moving around. Usually, you'd often use time to make it smooth, but we don't need to do that here. Okay, all right. Does that make sense? So we're going to move forward by that length there, and that's going to keep us moving around. We'll need to draw a line, so let's do that now. Okay, just checking my notes. So what we will need to do is we'll say vector 3 initial position. Should we say something like that? Initial position equals transform dot position. Okay, so we're going to be drawing a line between where we started and where we end up. All right, so let's just, I think that's all we need there. And now we say, this is the bit I struggled with, and you're going to be laughing, but this is one way of doing it. Debug dot, I mean, just bear in mind, this is only the first phase. In the second phase, we're actually going to create this and turn this into a 3D model. We're just kind of doing proof of concept right now. Okay, debug dot draw line, and we'll say initial pos, comma transform dot position, as in where we are now. The color, so let's make color dot white. How long we wanted this line to be around for, because it's a debug. You need to say how long it's going to be around for. So let's just put something silly in, like 10,000. So 10,000 seconds. And this one here, whether it's going to check on the camera or not, we don't really care about any of that nonsense. So we'll just do that. Okay, so that's going to draw us a line. Good. We're off to a good start. Now what we'll do is we'll say else if brackets current character equals let's do the plus, shall we? And then we'll say, well, this is transform dot rotate, isn't it? So it's going to be transform dot rotate, and now you need to say which vector you're going to rotate it around. Now I'm using the y angle, which is the up angle, if you like, the angle that points into the sky. So if you rotate around that is the sort of angle. If you look down, that would be the angle you were spinning on. So we'll say vector 3 dot up. And then it's going to be well, what we should do here actually is we'll create up here. Let's just add a private float angle. Okay, and we'll just set here angle equals, I think 25 degrees is what we're after. I think. I'm always curious whether I should put F on the end. I sort of, sometimes I do, sometimes I forget, but it never really matters. Okay, vector 3, and then we'll say angle. I think that's all we need to do here. Vector 3 up, this times angle, isn't it? Excuse me. Times angle. Yep, and then we can do effectively copy the same thing, can't we? We said we're going to Control C, and then just end like that, and then just do minus there, and then minus angle. Okay. Okay, so with that done, what we'll now need to do is we'll need to work out ways to create this so-called stack. So what I've actually done is I've created a class called transform info, and it's got a couple of things here called vector 3 position and a quaternion excuse me, rotation. Alright, so should that be a vector 3? I'll give it vector 3, I think. Oh god, now I'm confused. Okay, we'll give it vector 3 for now. Okay, so we'll have a position and a rotation. And what we'll need to do is we'll need to create a stack, which is a C# object, and very simply put that into our lSystemGenerator.cs file. Stack's already written for you in C#, so you don't have to worry about any of that. Okay, so that's good. So if we go down to here now, else if brackets, let's just copy this, shall we? And it's going to be the open brackets. So what we'll do is we will say, what's it? Transform info. That's ti equals new transform info. Like so, and then we'll say ti dot position equals transform dot position, and ti dot rotation equals transform dot rotation. Okay. And then finally we can say transform stack dot push brackets ti. Now, did I do that right up here, by the way? So one thing I wanted to check. Sorry, I haven't added it here, have I? So let's just do that. That's what it was. Equals new stack of type transform info. Generics, people. Never worked out why. Am I still recording? Yes, I am. A horrible feeling I was on pause then. Right, and I wouldn't have known where I finished and where I started. Right, so we've got a stack here, and we can push stuff onto it. Good, right? We've got and we can carry on then, right? So okay, so we've got our position in rotation, and we can just carry on round in the next character and see what that character's telling us to do. And so, but then also, in fact, let's Control C. Let's go down to here. Let's do that. If characters character is that, not that, excuse me, if it's that, then what we do is we say transform info ti equals transform stack dot pop. Lovely word, isn't it? Peek, by the way, means you can have a look at it, but you're not taking it off the stack, so you can actually see what it is. Okay, and then we say transform dot position equals ti dot position and transform dot rotation equals ti dot rotation. Okay, good. We're in reasonable shape here, I think. So you can see that every time we generate now, it's going to go through. It's going to create this new set of strings. Okay, and then it's going this. By the way, this so each generation will the game object will end up in a new position, which is why you don't want to sort of restart back at the starting point, because I think for each of these, every time you generate, the game object will start in a slightly different place. All right, so that's why each generation should do this bit here as well. Okay, one other thing that I've realised is I'm going to have to. The rotation is not a vector 3; it's a quaternion. There we go. Shift Control F10. Shift Control S rather. Excuse me. Are we still recording? Yes, we are. Okay, so let's give that a go. Let's give that a go right now. Get rid of you, and then run that. And we're off. We're off to a reasonable start, but it's massive. Okay, relatively happy with how that looks. I think that looks pretty cool, don't you? One thing I've realised is that every single strand is the same length, so we can fix that pretty straightforwardly. Straightforwardly, is that a word? Pretty easily. But just by saying here, we'll just say len equals length divided by 2. I think I called it len in my first test. Okay, so Shift Control S. Okay, let's have a look now. It's going to be half the size to start with, isn't it? As soon as it runs the first one, so it's going to be a lot smaller. In fact, so let's just sort that out. Let's just make that. Let's make the length twice as large here. 10. Run that again. Okay, here we go. That's a bit better. There we go. You can see now that we're getting these smaller and smaller branches. That's fabulous. I'm loving the way this looks. Let's give it one more iteration, shall we, just for fun? Okay, run that. See how that looks. There, look at that. Now that to me is pretty damn amazing, considering all we've done is a very simple rule, just kind of bounced around, this thing bouncing around, going backwards and forwards, loading stuff from the stack, moving its position around. How cool is that? So let's add a little bit of a twist to this. Let's make it so that it can we can see it while it's working. Now you may have to bear with me while I code this in. Let me just make sure I'm recording. My apologies. I managed to mess up the recording a minute ago, so I'm hopeful that I haven't lost anything and I've suddenly lost track and you're going, well, hang on a minute, you did this. If I have, my apologies. I'm having a few problems with XSplit right now. I don't know whether it's me or whether it's XSplit. It's probably me. Right, yeah, so let's make this something a little bit more interactive. So we'll have an I enumerator, and an I enumerator is something that allows us to run things in the background, and we'll call it generate L system or something like that. Generate L system. Okay, and this is just going to do. It's going to say we're going to say int iterations equals let's just say int count equals 0. Okay, for now, and then say while brackets count is less than 5. And what we'll need to do is we'll need to know this is the method we're going to call in the background. So we're going to need to know if it's running. We don't want to run it 5 times in quick succession. So what we'll do is we'll have a private bool is generating, something like that, is generating, and that equals false. Okay, yes, fine. And then here we'll say if brackets not is generating. So if it's not doing anything, then we'll say is generating equals true. We will start our coroutine. generate. Okay, and this we need to make this an I enumerator as well, because it's going to be running in the background. Okay, I enumerator generate. Say what? Otherwise, say else yield return new wait 4 seconds 0.1f or something like that. Okay, right. How's that looking? We can get rid of those ones, and in our start method now we'll just call start coroutine. Start coroutine generate L system. Okay, I think that's right. So that's going to generate the L system in the background. Okay, this is going to call this every time. But at the bottom of generate now, we need to say is generating equals false, as in I finished. Thank you very much. If that didn't make any sense, I'm sorry. I'm really sorry. Let's just give that a quick go. Oh no, but if we're going to actually do this, we need to return something here to give the frame back so that it can draw the frame. So I think we'll do it in the forward one here. We'll just say yield return. I can't type today. Null. There we go. Shift Control S. I think that's going to work. Let's just put a break there. So what we're saying here is every time you've gone forward, yield return null, which basically means I'm done for this frame. That's how I take that to mean. So it's not going to do this, or it's not going to, this whole process isn't going to have to complete before you can draw the frame, I think. All right, let's give it a go. Go back into here, and I'm hoping. There we go. Look at it. It's going nuts. Maybe I've got a bit of a cough. Okay, that's pretty crazy, and I like it already. Now, did you see that? Did you see where it bounced back to a sort of an original position? That's where this stack thing is doing its job, and it's sometimes the stack can get pretty high. I'm thinking. We can have a look at the console, can't we? Here, let's just drag that down to here. Pull this up. That's this one here. Look at it. Look at that. Wow. And I wonder how many brackets. Oh my goodness, that is a mighty amount of text, isn't it? You can see there's 4 brackets at the end there. So you can imagine then that it must be the stacks must be getting pretty serious in terms of where it's storing its positions. But for me, that's a really cool looking thing, isn't it? That's really, really doing the job. Okay, I mean we can go into stuff. We could perhaps start saying, well, if it's the last iteration, change the colour to green or something so that it looks like a leaf. I'll leave that up to you to have a play around with. There was one thing I was going to try. And that was going back to the L system here. I couldn't get this to work earlier on. Let's just see if I can find it again. Where are we? This one here. These Sierpinski triangles. It looks like it's got a pretty simple set of rules. So we've got a couple of variables now, F and G. We haven't got a stack anymore, but that's okay. We can keep it there. It's just not going to get used. And what it's saying here is F and G are both draw forward. Plus means turn left, and minus means turn right. Okay, so it should be pretty forward. The angle is 120 degrees rather than 25. So let's just give it a go. Let's just run the numbers in there now. Let's just do this. So back to our script. What I think I will do is just set that to a semicolon there, and I'll just put the axiom in the rules here. Axiom equals F. Okay, and then we've got. Yeah, so we'll put that down the bottom. Okay, and then we can check. We'll just comment these ones out and try the other ones. Now this is stuff on the fly, guys. This is what I was saying about don't do things, don't try things unless you've tested them first. So I'm breaking my rule already. So the axiom is F minus G minus G. Okay, this doesn't always work. No, look. Okay, I'm just going to type it in F minus G minus G. Okay, and then we have our rules here. So if it's F, then we do that. You can see we're going to have to add a new rule for G, aren't we? But G and F both mean forward, so that's fine. Excuse me. And yeah, now let me just try this. Now what I have to do here, I think, is do a new line, then just do Control X, and then go into here. I know this is stupid. This isn't a Control C, and I think I can now just do Control V. There we go. Okay, so let's just Control X that there. Put that in there. Like so. And I think for G, it was quite simple, wasn't it? It's just GG. Okay. So change G to GG. the horses, the GGs. There we go. The angle's different, isn't it? The angle is, the angle is 120. I think the length can stay the same for now. Okay, so down here we need to say if it's F or Q, current, come on, help me out, current character equals G. Okay, everything else should be fine because plus and minus are changing the angles. We've got 120 degrees, F and G, and it doesn't do anything fancy, does it? It still adds those characters in up here. So if it's got those rules for F and G, which it has, and it's going to change them for us. Okay, let's give it a go, shall we? Okay, people, get excited. Oh no, that's not worked at all. Okay, well it's done something a bit odd. Oh look, it's getting smaller and smaller. So now it looks like, look at that. Well, it's certainly done something. I'm what? What the? Okay, that is nothing like a Sierpinski triangle, is it? But I am liking what it's doing. Okay, let's have a quick look at this. I knew I shouldn't have done this on the fly. Is there any space I'm supposed to store them? F and G, turn left and turn right by angles. It's possible to approximate. It doesn't say anything about storing them, does it? Plus means left, turn right. Well, there's nothing there about that. I mean, maybe I'm missing something. That's frustrating. I want to have a go at this one, but I'm conscious it won't work. But look at that! Look how cool that it's doing this really weird thing. I'm going to stop it. I encourage you then to have a play. And don't do what I do, which is just try it on the fly. See if you can fix it before you demo it on YouTube, if you are going to do that. There we go. S. So now if we run this, I think we'll be back to our one that we're happy with, which is our beautiful tree. And there it is. Now, so in the next episode, guys, what we're going to do is I'm going to actually turn this into something 3D. So it's going to come out not just in a flat plane like that, but it's also going to come out along the, the Z-axis. Okay, so it's going to move around on the Z-axis. And then, if there's enough desire, we'll turn this into something even more amazing. If we just quickly go back to here, I'm going to try and shoot, yes I am, for one of these guys. There's no reason why we can't try something like this. Can I zoom in? There we go. I can't zoom in. I can probably zoom in like that. There we go. Yeah, so I think we should try something like this. Why not? These little fractal trees here. Look at that one. It's like a broccoli tree. We're going to try those. We will succeed. So thank you very, very much for watching. As always, I love any likes and I love comments. I do try and help. A chap contacted me the other day. He's been working on the dungeon tutorials and really working hard on them, so I really appreciate that. He's found some bugs in my code, which is disconcerting but not unexpected. So thank you very, very much for watching, guys. I look forward to speaking to you soon. All the best. Cheers now. Bye bye.